This is a problem work through for problem number 55 from lesson 2.5, Velocity and Acceleration, Graphical Modeling and Interpretation. Now, in this problem, we have to take some information from this graph, from this image. And for part A, we need to actually fill in the data table here on the right. Now, we have time in seconds and we have distance in meters. We are told that here in the problem that this little person is walking along a sidewalk that is marked in 1 meter increments, and we're given snapshots at regular time intervals. So for time, we have 0 seconds, 2 seconds, 4 seconds, 6, and 8 seconds. So we can just go ahead and fill that in down here. So 0, 2, 4, 6, and 8 seconds. Now, for the little person, if you look close, you can actually see his front leg is bent here at the knee, and then it comes straight down onto that. So we actually have, this guy is at 32 meters, this guy is at 24 meters, this guy is at 16, this one here is at 5, 6, 7, 8, and this one is at 0. So we'll record those values here. We have 32, 24, 16, 8, and 0. Now, for part B of this problem, we actually need to draw a graph. So let's start by actually taking our graph and writing the, the information that we need. So first off, we need to title our graph. So this is going to be a position versus time graph. We're going to have position on the vertical axis, and that's measured in meters. And we're going to have time on the horizontal axis, and that is measured in seconds. Now we know that this point is going to be our origin, so that's 0, 0. But if we look back at our table, our time is going to go from 0 to 8, and our position is going to go from 0 to 32. So we have to determine a scale that is appropriate for this. Now, it looks like there's far more than 8 here, so I'm just going to go ahead and pick 3 marks. So this will be 2, this will be 4, this will be 6, and that'll be 8. Now, the reality is you can pick the scale to be pretty much whatever you want. Just make it fit within the graph. Don't draw extra lines on the side or this or that. And don't squeeze it all into this bottom corner. Now, going up, I think there's 20 marks up here, so I'll do every horizontal line is 2. So this is 2, 4, 6, 8. So that makes 10. That makes 20. And then we'll do 2, 4, 6, 8. That makes 30. All right, so I'll do my points in a different color. So our first point is going to be where t is 0 and x is 32. So t is 0. Now our position is going to be 32, so that's going to be up here. Our next point is going to be 2 and 24. So we come over here to 2, we go up to 20, that's 22, that's 24. We have 4 and 16. So 4, 10, 2, 4, 6. We have 6 and 8. So 6 here and 8 there. And then our very last point is 8 and 0. So 8 and 0 right there. All right. So that right there is a graph. Now, once again, for full points, you need to have a title. You need to label your vertical axis and your horizontal axis. You need to have numbers showing your scale on the horizontal axis and the vertical axis. And then, of course, you need to plot your points. You do not need to draw a line to connect the dots. Just what you have here is perfect. Now, let's answer the 4 critical questions for this graph. So our first critical question is where we begin. So we can see that we are starting here at 32. We are to the right of the origin because this is positive. So if we were to imagine this is a number line, This would be to the right on the number line because it's a positive value. So we are right. All right. Question number 2 is asking what direction this object is moving. And we are moving to the left. Now you can determine that by this is our starting point. We know this is our finishing point, so its position is going to be here. We have to move down, right? We have to move to the left in order to get from here to here. So we are moving left. Question number 3 says, is this object speeding up, slowing down, or remaining at a constant speed? Since we have a straight line, we know that this is moving at a constant speed. And then question number 4, where do we end up? Where's our finishing, our final position? We're here at 8, 0, so we are at the origin. Okay, so now our final question is we have to determine the velocity of this little man. Now, let's start off by writing the formula for velocity. We know that velocity is the change in position over the change in time. So that gives us x final minus x initial divided by time final minus time initial. Now, in order to find these values, we need to pick 2 points. So I'm just going to go ahead and pick our first point and our last point. All right, so moving back down here, our initial point is going to be 0 and 32, and our final point is going to be 8 and 0. Now, just as a reminder, when we're doing these, this is t comma x. That means that these values are x and these values are t. So when we plug these into our formula, we have 0 minus 32, final minus initial, so 0 minus 32 over 8 minus 0. Scoot that up a little bit. So we end up with negative 32 over 8, which reduces to negative 4. Now, since time is measured in seconds and position is measured in meters, we have meters over seconds. So we have negative 4 meters per second. And that is our velocity. All right.